Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So this week we're going to finish the tachometer installation on this lathe. This is actually the third video in a series of installing a tachometer on this lathe. So if you missed the previous two videos, I will link them down in the description of this video, and I'll probably just make a playlist of all three as well. So if you did miss those videos, definitely check them out because we've already solved essentially the electronics end of this. We know what parts we need to use. And we have designed and 3D printed the tone ring, which is a ring that is pressed onto the spindle here. And where each one of these white dots are, there is a magnet embedded into this ring. So what we now need to do is come up with a way of holding this board here, because this board, sticking off of that is our Hall effect sensor. So as this ring goes around, it's going to trigger the sensor each time a magnet passes in front of it. And we can't just like tape it in here. It's got to be held in some fashion that it is going to be reliable and also pretty durable as well, because grease and chips and things get flung around inside here. Normally there's a cover that goes over this end of the lathe. So we need to make sure that it is going to hold up to regular use. So where we left off is I did a 3D scan of this whole part of the bearing cap here for the spindle, and then modeled this piece here just to kind of test that we key up against everything properly, because I think we're going to use, there's an M8 hole here that I believe is in a shaft, a blind shaft that gets pressed into the casting here. And I think that's actually for removing this shaft. I think it's just pressed into place. I believe we would normally thread something into there and then use a slide hammer to remove it. So we don't want to torque on there real hard because I don't want to break this shaft loose, but there's no reason we shouldn't be able to use that to just hold a small bracket on here. And maybe we'll put some Loctite on the bolt when we have everything the way we want it, just to keep it from rattling around so we don't have to make it very tight. And this test piece that we made fits very well. Now this doesn't actually get us to where we need to be in holding this board, but it did confirm that all of our modeling here for our curves and the height of those faces relative to this flat part of the casting is all good and set to go. So the next step is going back to the drawing board and figuring out how we can, starting from this model, adjust this to be something that actually gives us the ability to hold this board very precisely, sort of protects the wire. I don't think we really need any adjustability. We just know that we need that sensor to be within a certain distance from the magnets that are embedded in here, which I think we have plenty of space to work with. And I guess we want to keep stuff out of this as well. It doesn't need to be watertight, but it should be able to protect things that are just flung off of these gears or that might be moving around in here in the future, maybe parts off these belts from getting at this sensor. So, all right, I'm going to go see what I can come up with, and I will bring you guys back. All right, and here is the initial design that I came up with. I basically took the test piece that we already had, and I just filled out the rest of the geometry. I created a pocket in here for the wire to come down through. We'll have to figure out exactly how the wire is going to exit this. We'll probably integrate that into whatever cover goes over top of this. And even though I don't know how that cover is going to work yet, I figured there's no harm in just adding 4 holes in here to mount it. And I was careful to have the holes here towards the sensor side drop into the area where I do have solid material. You can see if I was any further over, matching the distance from the edge like this side, I just wouldn't have enough meat there to get those screws in. Which actually brings me to my next point here as well. So I put a recess in here for the circuit board. You can see that is pretty thin. I don't think I have room here for screws, or I just don't even know if I can get screws that short without modifying them. And I think, you know what, these plastic studs really should be fine for retaining that board. So I put a recess in, and my thought is the recess is what the board is going to key into and is going to keep the board from, moving in this axis or in this axis. Really, the studs here are just going to hopefully lock it in place so that it can't move around as we assemble this and as we test it as well. So, all right, let's get this printed out and see how we did. All right, and here is that piece printed out. So let's see how things line up. Let's try our sensor first. It should just press right on to here. And it does not. I think, yeah, it looks like I'm a little bit off on the position of these pins to lock this into place, and it is just a little bit narrow. You know what's going on is this area is unsupported when it's printed. So I think that's drooping a little bit. I'll have to raise that edge up and adjust the position of these pins. But let's see how things line up. Okay, so that's not bad. I don't like the sensor just kind of sticking out there by itself though. I was thinking that when we designed the cover for this, we'd have it sort of protected, but it actually looks like it might be too far out. All right, I think I'm going to go back and I'm going to adjust the position of these pins, and I'm going to move this whole thing back a little bit. Also, this area looks really tight for the wire. I think we're probably going to have to ultimately adjust that as well, just for to have room for the wire to come down in here and exit out of the side without being in the way of that bolt. And I'm also just realizing I think I forgot to decrease the diameter of that hole for the bolt. Let me grab the bolt. Yeah, that hole is way too big. I meant to size that down from our test print. I made it oversized at first just in case we weren't really on center on that bore, but we are, so this needs to get sized down much closer to this. Although, yeah, it doesn't actually fall through. We could still try it on there. So we can confirm our position now. Yeah, that's a little bit closer than I want because I want to bend this guy out a little bit. And we are not, yeah, we're also not, you guys can't see from that angle, but we're not, from a depth perspective, we're not centered on the tone ring. All right, let me go back. I'm going to whip up a, this is V2 or V3, quick. We'll adjust the position of those pins. I'm going to decrease the bore for that bolt, and let's try that. All right, and just like that, our updated piece is done. Let's see how the board fits in this one. Okay, the pins are lining up. Still doesn't want to press into place though. I raised this edge. I might not have raised it enough. Now it fits in there. Oh, you know what? Oh, I totally, these are through-hole components. I completely forgot I needed clearance on the back of the board for those. So, all right, that's not going to press into place, but we can check the other stuff. So I reduced the size of the bore as well. Let's see how this fits on here. Yeah, it's the right size for that bore now. Yeah, from a position perspective, I think that's good. It's probably, from the angle you guys are at, it's probably looking a little far from the ring now, but that's okay because this can get straightened out more. And yeah, once it is, I think it'll be dead centered on the tone ring here. So, all right, that's probably good. That's definitely bolting up in the right position. All right, let me go revise this again with a relief here underneath for the through-hole components here. All right, and here is my revised design for this. And probably the first thing you'll notice is I did go ahead and do the design for the cap or the top cover for this. And I've got a notch cut out of this so that we can have the sensor sort of sit in that space, but hopefully still be protected enough top and bottom. And I've got 4 counter bores in here for some socket cap screws. And I sized this that with at least the screws that I use, the head of the screw should sit basically flush with the surface of this once it is in place. Also designed this sort of curved feature here and then curved feature here, this curved cutout in this lid. And this is, the distance from here to here is just slightly less than the diameter of the cable that I'm using for that sensor. So this should pinch it just slightly and lock it into place. So let me go ahead and pull this off. We'll take a look at the inside. So inside you can see I added the recess for the those through-hole components on the back of the circuit board, and also added a slight chamfer here on those studs that are going to lock that circuit board into place. And I did have to increase the thickness of this cross section here, which means I'm going to have to probably bend the leads for that sensor just a little bit just to get back to the center position. I had to do that to get this recess here for those through-hole components. Without that, there just was not enough room to accommodate those. So, all right, let's get these 2 pieces printed out and see how we did. All right, this looks really good. I printed the cap and the bottom piece. So let's see if we have enough clearance for that board now. Yeah, that fits in there. I don't know if you guys can see that at the angle, but that presses in really nice now, so that is good. We have more clearance for our wire. Let's take this one off and try it. Okay, hopefully that'll stay in place while we test this. It's going to be tricky too. I know you guys, let me see if I can get you a better angle so you can see the sensor here. The trick is I'm trying to line it up in this slot. All right, hopefully that gives you guys a better view as to what's going on in here now. So I am trying to position. This is tricky because the board wants to pop out when I bend the wire. I think the sensor's lined up. Yeah, the board's popping out. So this board is going to be captured in here once this piece is bolted in place, but until we get that bolted in place, we just kind of have to keep it in position. Okay, I think that's in. Okay, I think everything is lined up. I'm going to try putting our hex cap screws in and see if we get a reading. Because again, that board's not actually locked in place until this cover is on. Now, I did not tap these holes. I sized it as such that these should basically self-tap as they go in. This is a fine pitch. I think this is an M4. Yeah, they're starting in there, no problem. I basically designed the holes to be the same drill size that you'd use if you were going to tap it, and then I just kind of tap it with the screw. It's hard going in the first time, but after that, it's good. Now, if I was going to be in here all the time, like if this cover was going to be coming off on a daily basis, I'd probably do like heat set inserts so that these holes would never wear out, but chances are, once I have this all installed, I'll probably never be removing this cover. So this is just fine doing it this way. I'm just going to put 2 in to test it. You kind of feel that pinching down on the board. All right, looks like the gap is closed up. Let's try it. Okay, that seemed to work well. I didn't see anything contacting and we were getting a reliable RPM reading. I grabbed the flashlight here because I really don't like that sensor being exposed. It gives us a really nice tight gap, but I think we have more distance to work with, and I'm afraid that something's going to eventually make its way in there and push that sensor back, maybe even break it off, and we're just going to be back in here replacing parts. So I'm going to see if I can come up with a way to have that sensor covered, still keep the gap that we need, and I have a thought for retaining this wire as well. If you recall, when I put this in, it was really hard to keep the board from popping out while holding the wire where I needed to go through the exit part that's cut out there on that cover. I have an idea for that too, so let me go whip up those 2 changes and I'll bring you guys back. Okay, I've made 2 changes to the design. The obvious one is I have closed up the end. So this is the end here that is facing the tone ring. What I've done is basically just done like a cutout inside. I did this 0.84 wide. Reason being 0.84, the line width is 0.42 for my print settings. So I basically just doubled the line width, so I know I get exactly 2 passes of solid plastic material without any like partial infill. And for this bottom piece, I actually integrated, hopefully you guys can see in this light, it's a black part, it's hard to see, but where the wire exits, if I put this back on, where the wire exits down here, I actually integrated a slot and recess in there for a zip tie to go through, so that once we get the board in place and the wire here, we can put a zip tie through there, pull that tight, and then it should keep the wire where we already need it when we put this cover on, so we don't have to worry about this closing up on that wire and potentially pulling the board and the sensor out of place. So let's try this. Oh, we should probably have that out so the lathe can't start while I'm working on it here, huh? Oh, that's cute. We actually stopped over one of the magnets. Okay, I think the zip tie is going to be really tricky to try and feed through there after we have everything in place, so I'm going to do that now. All right, I've got it started through there. I'm going to grab pliers to pull this through. Okay, that zip tie is a tight fit there, but that's okay. It should be. So we need to put our wire through here first. And I guess actually this needs to be bolted in place first, because we're not going to be able to get at that bolt head while we're positioning the wire. Yeah, this board does not want to stay in place. I had hoped that with that zip tie there, that guy would kind of stay on those little studs better. Okay, I got that together. I don't know if this sensor is still in the right place or not. Let's just try it. All right, guys, it's actually a couple days later. I was going to use this as the final design. I was going to pop 2 more screws in this and then move on to figuring out the wire routing and call this good. The reality is, it's not good. It works, yes, but I've fallen victim to something that's very easy to do when you're doing design work like that, and that's getting attached to earlier design decisions that I made and refusing to acknowledge the shortcomings of that design. So let me pull this cover off. I'll show you what I mean. Yeah, that sensor was bent way out of position. It kind of just flopped back, but it was bent way out of position. So the main problems with this design are, well, first of all, the zip tie is too big. That's an easy fix. I can go find a smaller zip tie. It is actually pushing this piece out. It was not sitting flat. This piece was getting pushed out like that. So eventually that PLA was going to creep and not line up anymore. And the board doesn't stay in position. If I just touch this guy, it's going to fall out of there. Yeah, and it doesn't want to stay in position. Well, now it wants to stay in position because it's been there that way for a couple of days. But it's impossible to get that sensor lined up into this groove here reliably. And if I ever have to open this guy up to service it, I'm just going to be fighting with it all over again. So I have made a number of design changes to dramatically improve how everything gets assembled, and also gives us some additional features. So rather than, it's all printed out, I've got it right here, but rather than show it to you here, let's go up to the computer and I'll walk you through all those design changes before we install it. All right, and here is our final design with all those revisions. And I promise this really is the final design. It's already printed. I'm just gonna give you guys a quick tour of it. So first thing I'm gonna do is we'll just pull the lid off so we can kind of see inside there. And I actually went ahead and modeled the circuit board so you guys can see what's going on in here. And also I used it for just a tool when I was modeling the changes here. But you can see the big difference between the previous design and this one is the sensor now sits inside this little pocket. And I'm going to go ahead and hide this so you can see kind of what's going on here. But there is a recessed pocket in here, and the distance between this face in here and this face out here is exactly the same as the distance that we had in the previous design when the sensor sat kind of inside the cap itself. It's 0.84 millimeters, or exactly 2 line widths in the printing profile that I'm using. So that's about as thin as I would want to go and know that I can count on the strength. It's going to be 2 solid rows of plastic out of a 0.4 millimeter nozzle. And the nice thing is we now no longer have to worry about trying to get the sensor in the right position and then slip the cover over and hope we didn't bend it out of the way, and we don't really know because we can't see in there. Now everything occurs inside or really on our base part rather than happening when we put the cover down in place. We're not counting on the cover to do anything other than being a cover, which is really how it should have always been from the start. Just realizing, I don't think I actually ever showed you guys how the design for the zip tie works. So here, we'll turn on hidden geometry, and I'll whack the side here. You can see that basically is just like a cutout inside the model here, so that when we push the zip tie in over here, that ramp sort of pushes it down through the circle, pops out, and it is retained as such that when we cinch that down, that wire is captured. So even if something yanks on that wire, it's not actually going to pull against the solder joints or the pins up here in that part. So to the cover, notice there is, well, number one, there's a notch cut out of the cover now for that sort of pocket or holder for the sensor. And this is also now a couple different pieces. So what is that part there? You notice that's actually a separate solid model there. I did that so that I can tell Bamboo Studio to print this part in white. We'll have a nice white dot there on the design that will line up with the white dots that come around on the tone ring. So we'll know from a diagnostic perspective when the magnet is positioned exactly in front of the Hall effect sensor. And sure, I mean, it's not that hard to kind of guess where the center is, but now you're not guessing, you know exactly where that sensor is going to sit. The other thing I did was I'm going to add a clear window here so that hopefully we can see the LED on the board. I don't know, here, let me get rid of, okay, now we can see from the back side here. I positioned that window right over where the LED on the board is. So that LED is going to be, I mean, there's going to be an air gap there, but the LED was pretty bright. What I'm worried about is, I mean, this is, let's see, what was my thickness on this? That is 3 millimeters. So we're counting on that LED light to come through 3 millimeters of clear PLA. Not 100% sure how well that's going to work, but I figure it's better than nothing. Even if I have to turn the lights out in the garage if I'm diagnosing this, being able to see that LED light without taking this cover off would be nice. So, and on a side note, you know, people always ask me when they're shopping for a new 3D printer, particularly if it's a Bamboo one, hey, should I get the AMS? And, you know, even if you're not into multicolor printing from doing, you know, minis or anything like that, which, you know, I'm not into, it still really comes in handy for stuff like this. I mean, I'm going to have 3 rolls of filament in for just the print of this cover. We'll have black PLA for the cover itself. We'll have white PLA for our marker dot here, which should come out really clean because we're printing this. This is the face that goes down against the bed, so we should have a nice textured finish on all this. And then clear PLA for our little window. I mean, there you go. There's 3 different materials in a really simple engineering print. So, all right, let's go down and see how these components work. Okay, and here is the prints for the final design. You can see already, you can see sort of that little clear window here, and you can see that white dot that is going to allow us just to troubleshoot this in the future. We know that when the small white dot on the tone ring is lined up with a large white dot on this cover, that we are directly over the sensor. And you can see we now have that slot here, which mates with the end piece here. And we've got that little pocket for the sensor to sit into and the actual screw holes to hold that into place. So let's get this guy bolted up. Oh, and I dug up a much smaller zip tie. So this guy, we'll probably still have to curl it to feed it in, but this should feed through a lot easier. Oh yeah, look at that, fed right through. We don't even need the pliers. I think I'm going to put Loctite on this bolt. I mentioned early on, I don't want to tension this real hard. Normally on a plastic part like this, cinching down to a cast piece, I would just snug it up until I knew I was flexing the plastic just the tiniest bit, and that alone would lock it into place. But I don't want to tighten it that much because I'm afraid of twisting the shaft. So I'm going to put a little bit of I think it's purple, whatever the weakest Loctite is, that's just going to prevent this from just rattling out. Yeah, so this is the Loctite 222 thread locker, the low strength. This is the please stay in there strength, which is just perfect for this. You guys remember at the beginning of the first video when we figured out the electronics and I said, don't worry, I'm not actually going to use this janky mess in production? Yeah, turns out I was lying. Oh, maybe we aren't using this in production. That's actually, that one wire is broken off. So at a minimum, we're going to have to solder that back on. I guess that's what I get for making a joke about it. Okay, so a while back on the channel, we actually made this part. This is an adapter to go onto a Bosch cordless tool battery that brings us out to an XT60 so that we can use a cordless tool battery for a Pine-Sol soldering iron. I'll link this video down in the description as well if you want to check it out. It's a pretty neat design that uses some metal plates in here that are captured within the 3D printed parts, and then it all bolts together so that when this slides into place, these plates come in contact in here on the contacts on the battery. I also need to make sure that our sensor is sort of sprung a little bit into that pocket so that when we get this in place, it's making contact down on the flat face of that pocket. And here is our tiny screws for attaching that board in place. These are M2.5. I'll link all the hardware that you need for this project down in the description of the video as well. And if I forgot to mention it before, all the STLs for all these parts will be on the site, fpfdesigns.com. I'll link that down in the description as well. And everything's free. I don't charge for any of the designs on this channel. All right, I'm going to bring you guys in close so you can see what I'm talking about here. So if I push on that sensor, you can see it's not moving. It is just very gently sprung into that pocket. And I know it can't move around now because it is screwed into place. So I'm going to tighten up. I'm going to get our wire into position. I'm going to tighten up that zip tie. I'll get you back in the stand. All right, before we go any further, let's actually make sure that this is indeed still working. Yeah, so it turns out if you don't have the cable plugged in, it definitely does not work. All right, that's working great. I think it's time to actually go ahead and put our updated cover on with our little clear window here and our alignment dot and see how well we're able to see that LED through the clear plastic. It's so much easier to get this cover on now that we're not trying to line up the sensor while we're putting this on. All right, that's looking great, and I'm amazed at how well we can see that LED through that clear window. That worked out far better than I expected it to. So now if I shift this into, say, well, let's pull this key. I think I forgot to do that last time. I'm going to shift this into high gear because it's easier to turn the spindle by hand. Yeah, so you can see now, it actually triggers it from a pretty decent distance away, but we know if we line up those two dots exactly right that the magnet is directly in front of that Hall effect sensor. So that's working really well. Before we consider this good though, I probably should put the RPMs up. That was just at the lowest speed setting. We're doing 53 RPM, so I'm gonna put this, we'll go all the way up to the highest speed on this lathe and just make sure it's reading it. All right, that's working great. I think it's time to start figuring out how we're actually going to route this wire. Okay, I unplugged the other end so we can drop behind stuff here. I think what I'm going to do is just chase this wire here for the safety switch down into the cabinet. That hits this piece here and then drops in. And what I might do long term is I could actually just kind of come down to here. So, you know, we'd be coming down into this space here. I could come around the base and actually chase the bottom of the casting or the side of the casting here on the back of the lathe all the way over to where the touchdro box is going to be over here. Thing is, I'm not 100% sure where I'm actually going to mount that touchdro box, so I think for today I'm just going to drop through the cabinet, come out the bottom, and then just chase next to the power lead. Sometimes when you route a signal line next to an AC cable like this, you'll get an induced current from the AC current traveling through here. But this should be shielded, so I think we'll be okay. Always use flush cut snips when you're trimming zip ties. That way you don't end up with a sharp edge sticking out there to cut yourself on. Okay, so I think long term I'll probably want to come up with a better way to route the wire than chasing the power wire down here, but I think for right now that's going to be fine. Again, because I don't know exactly where I'm going to mount this. In a future video, we'll probably come up with a way to mount that whole touchdro box to the cabinet of the lathe, but I'm not ready to do that yet because I'm just not sure where I want things to sit. But everything is looking good over here, so let's get the side cover back on this lathe. Well, this is an added bonus. We can actually see that LED shining through there, even with the side cover on. And I think if I shine a flashlight in, I can actually see the dots to line up as well, just if we need to for troubleshooting without actually taking the cover off. All right, we've got this all buttoned back up, but why did we even install this in the first place? Well, the obvious answer is we can see the RPM on touchdro, but it goes a lot deeper than that. But let me show you that first. So rather than having to look over here at what we have the transmission set to and then looking up the figure in the chart, which isn't going to be accurate anyway, if we turn the lathe on, we can see what the actual speed rate of the spindle is. It's doing 104 revolutions per minute. But there's a lot more that we can actually get out of this. If I go into the Z-axis and I manually move the Z, so this is Z. Z is either moving away from the spindle or moving towards the spindle, typically moving towards the spindle. But if I turn that crank to move Z here, when I open that up, you can see not only the position is changing, but we're also getting a feed rate. And it's calculating that feed rate based on how fast this is moving. Now, we don't need the tachometer to do that, but we can tie the movement of this axis to the spindle by engaging either the power feed or engaging for threading. And threading is probably the easiest one to show you. Okay, so we're over here on the front of the lathe, and this is the transmission that controls how fast we're either power feeding or threading. So if we look right now, we are set to B, C, that's a P, yeah, P and X. So if we look at our chart up here, let's see, we have the 60 tooth gear on, so PX, BC. Basically, we should be feeding at 24 threads per inch, the way that this transmission is set up right now. And that sounds right because I think the last thread I cut on this lathe was 24 TPI. So we should be seeing 24 threads per inch being displayed as our feed rate for not chip load. That would show us how much we are, basically how aggressively we're running the cutter, but down here in thread count. Let's try it. And sure enough, there we go. It's moving around a little bit. There's probably the pitch of the thread on the feed rod is probably not exactly perfect, and our speed might be bumping around a little bit, but that is basically showing us that we are indeed running at 24 TPI. I should mention, if you're not familiar with using a lathe, it's not really that big of a deal to confirm your feed rates. I mean, it's nice to know that it's, running at the feed rate that you've set. But threading, it's really nice to be able to confirm before you start cutting your thread that you are actually moving at the correct rate to get the number of threads per inch that you need. And I can flip this to metric as well and confirm my metric settings on here too. So normally when you're threading, you do a scratch pass, which is you're just barely cutting into the material to make a mark and then putting a thread gauge up against it to check it. I'll probably still do that, but being able to set it and then confirm that it is moving at the TPI I have set without even cutting any material is going to be really nice. Well guys, as always, thanks for hanging out in the shop with me for this build series. I know this ended up being 3 videos. It was actually quite a bit more work than I anticipated doing, and I don't even think I showed you all of the different iterations that I went through. I really went down the rabbit hole of perfecting this until I was satisfied that it was at the level that if this was like a real product I was going to sell, or if I was designing it for somebody else, I would be truly satisfied with it. And this was a learning experience for me. I really thought that I was at the best design until I walked away from this for a few days. And then I came back and I was actually kind of just disgusted with some of the things that I was sort of letting go, like primarily the way that board was mounting inside of the original style mount, just on those studs. I don't know why I was so against having it screw into place in the first place. I think I was just thinking it would, stay seated on those studs a little bit better, but having that board screw into place and ultimately having a fully enclosed housing, I am really happy with how everything came out on this. So if you want to make one of these for yourself, a link to all of the parts that you will need, as well as the STLs, which I'm going to provide completely for free, will be, again, linked in the description of this video. They'll be at my site, fpfdesigns.com. And let me know down in the comments if you want one of these and you don't have a 3D printer. I may consider selling these. I've done that with a couple other things that we've done videos on, because people will reach out to me and say, hey, I've got the exact same machine, or I've got the same problem. I don't have a 3D printer. It's not a hobby I want to get into. Would you consider making one for me? Again, let me know down in the comments if you've watched this video and you'd like to get one of these for yourself and you don't have access to a 3D printer. If you got anything out of this video at all, do me a favor. Please take a second, hit the like button. Really helps out the channel. Also gives YouTube an idea of the type of content that you like to watch. And if this is your first time here on the channel, we do all functional prints. A lot of them end up out here in the shop, but I do stuff in the house and outside, in the yard as well. So if you're into that sort of thing, check out some of my other videos. And if you do and you like what you see, hit that subscribe button. And if you do, I'll see you next Friday.